Hello friends, welcome to the Tetrahedron chemistry classes. So in today's topic we will see the fragmentation pattern of alcohols, right? Let's see, this video is actually in the continuation of the mass spectrometry. In recent days I have terminated this mass spectrometry series because I was not getting the proper response about these videos, right? But again, some of you have requested me to shoot a video on the fragmentation pattern of the alcohol. So that's why I'm here today with this fragmentation pattern of alcohols, right? So now one thing what can happen, see this video right now I'm shooting from my home. So there may be little disturbance of voice due to my kids actually. So please guys kindly adjust, right? So before starting the mass spectrum of alcohols, you should focus some of the things, right? Also, whatever I'm going to explain today is actually given in the most of the spectroscopy or spectroscopy textbook, but this is the spectrometry, mass spectrometry. So these discussion which I'm going to make here, whether you can find in the spectroscopy by Pavia Lampman and Chris. It is the standard book actually, and in the CSIR net and the gate examination you will find the question from this questions from the topics where or say concept which can be built by using these books, right? I'm not saying that directly they ask the question from these books, but most of the concept would be there in this Pavia Lampman book. And another book which I have to mention here about spectroscopy, which is very very important, and the name of the book is the Spectroscopy by Jagmohan. See, it's an Indian author, but if you read this spectroscopy book, then you will find it's a very very good book, and it will give you the immense knowledge about the spectroscopy if you thoroughly go through the book. So it's again, see, it's Narosa publication by Spectroscopy by Jagmohan, right? So I am giving idea about the alcohol fragmentation. So one by one I'll discuss all the things. So initially I am focusing on the aliphatic alcohols. Aliphatic open chain alcohols, right? They are not cyclic. So as you know, the alcohols, the very famous reaction for in case of the alcohol is the dehydration of the alcohol. So actually these alcohols are very prone to dehydration, and this dehydration, see, it can occur in the sample in the chamber where when the ionization has not started. That means prior to the ionization, due to the thermal heat, this dehydration can occur, and this is the problem actually, right? And when this occurs, then prior to the ionization, this dehydration occur, then it is most of the time 1-2 type of elimination reaction, right? But if somehow your molecule survived, right, and if it undergoes the ionization, and after that ionization, if your dehydration occur, then this dehydration actually is 1,4 type of the dehydration, and this 1,4 type of dehydration generally goes through the cyclic transition state, right? So all these things we are going to see in a few minutes. So since these are very prone to the dehydration, so one thing is sure, if you are looking for your molecular ion peak, so it is not possible to get the molecular ion peak in case of the alcohols, as I have mentioned in my previous lectures, right? Where I made a point that it is not necessary all the time by using this electron impact ionization you will get your molecular ion peak. So alcohols, in case of the alcohols, according to me, it is not possible to get. However, you see, we can have the primary alcohol, secondary alcohol, and tertiary alcohol. But in case of the primary and the secondary alcohols, there may be a chance then you can find a very weak molecular ion peak, right? But in case of the tertiary alcohol, because they are very readily dehydrated, right, so it will not give you the molecular ion peak. And in case of the primary and secondary, it is very weak. Got it? So if you want to see, now the problem is that if you want to know the molecular weight of the compound, then surely you will not opt for this electron impact ionization. You should go for the other soft ionization technique, right? So you will not get your molecular ion peak. Tertiary, in case of the tertiary, it is absent. In case of the primary and secondary, it is present, but it is weak. And the dehydration reaction is very very common. So M-18 peak, it is very very important, right? So 18, 18 is what? It is the mass of the H2O. So when you remove the water molecule from there due to the alpha cleavage, right, then this 18 mass unit is formed. Or whenever the alkyl group is lost, and as I have mentioned in case of the alkane and other cases, right? So these largest alkane group actually readily lost, preferably lost, so it will give you the peak. Now this is something very important. Say if you are having your primary alcohol, you can see here RCH2OH, right? So this, if somehow this R is lost from here as a radical, then you what left with CH2 double bond OH kind of thing, and this is actually the very important ionization. And in your examination, if the question from your alcohol series, then definitely you should focus on this particular ion, and this will give you the M by Z 31, right, if the alcohol is the primary. But if the alcohol is the secondary, then you may have M by Z of 45, M by Z of 59, M by Z of 73. With the help of the example, we'll see how we can make them, right? So what happens, only one group lost and remaining, see, this was 31, right? And it is your, if you are finding that this 31, it is 14 mass unit. If it is, then it will give you 31 plus 14, that will give you the 45, right? So 31, if you add 28, that means C2H4, then you will get 59, right? Similarly, you can see we can have the various kind of things, right? And if you have the tertiary, see this kind of alcohol, this is tertiary, where the three alkyl groups are attached with the carbon itself, then you may have 59, 73 and then 87, right? Again, you can add 31 to certain mass unit, this in this 31 to get the 37, right? So these things you should note down. And as I have mentioned already, if the prior to the ionization, if the dehydration occur, it would be 1,2 type of elimination. If after ionization this dehydration occur, it is actually say elimination of water molecule. See this 1,4 elimination. And finally you can see if your compound is having, see this is again very important point in case of the aliphatic alcohols. If your compound is having 4 carbons or more than 4 carbons, then you will have this M by Z 42 type of peak, because first what happens is water molecule lost, and after the loss of this water molecule, and ethyl molecule is also lost. So this type of mechanism I have shown in case of the aldehydes and the ketones also, where we were discussing the Mac-Lafferty rearrangement. But right now this is not a Mac-Lafferty rearrangement, right? If this is not a Mac-Lafferty rearrangement, then definitely it will be some different kind of the mechanism. But what is happening here, you can see here, first what would happen, this double bond would shift over there, and one of the hydrogen along with one electrons would go there. This will remove water molecule, right? And of course now you left with the one electron, and this one electron actually would then come here, and this would go up. So CH2 double bond CH2 we can remove from here, and what left actually, CH double bond CH2 and R, right? From where we are getting the double bond, actually it is a one electron movement, so one electron is already there, so it can come from here. Then I will draw the mechanism of this one, but for timing you can understand in this way. We can have this one, right? So this is in case of the primary alcohols. Now very quickly we will see how we can see the spectrum of these alcohols, right? So you can focus on this one, right? Here you can see this compound is actually your pentanol, C5H12O. If this compound is the pentanol, so you are getting the peak at 88, right? But this is a very weak peak. As I have mentioned, in case of the alcohols, the molecular ion peak is very weak, and you can see it is hardly detectable actually, though however it is the primary alcohol, but again we are not getting it actually. Now if you are looking at the peak at this 78, obviously you would know this is your 88, and if you subtract 70 from it, then of course you will get the 18, right? That means this difference is actually due to the removal of the water molecule, right? This is how you can assign. So now you can see how we can remove the water molecule from here, right? Just say you have this molecule CH3, CH2, 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 and again CH2OH. This is a pentanol type of thing, right? So now I am not going to draw the entire mechanism, as I have mentioned all these things earlier. So what happen, you see, this will get the odd and the positive. This is actually the molecular ion. This is the molecular ion. This is the correct way of representing it, right? So guys, as you can see, as you can hear, this there is a noise problem as my kids were disturbing here. So please kindly adjust these things. Right now, this is what this is giving you the 88, right? Molecular weight. Now the dehydration would occur. Now assume this dehydration occur. If you are assuming it is 1,4 type of elimination, right? 1,4 type of elimination reaction. So what is the meaning of that? This is 1, this is 2, this is 3, this is 4. That means you will remove hydrogen from here, and we will remove OH from here, and finally you will get water molecule. So right now I am not drawing the mechanism type of thing. You should learn this mechanism by your own, as I have discussed all these things in my previous videos. So what you can get here very easily, you can get CH3, CH, CH2, right? CH2 and again CH2, and what I can do, I can put say positive and dot on it. In this way you can draw. If you count this 1, 2, 3, 4, 5, 60, 63, 64, 66, 68, 70. So you are getting the peak at 70. So this 70 you can explain in this way. Positive and dot you can put here. Right. Now if you see the spectrum, then another important peak is actually at 55. Right. M by Z of 55. However, if you go through the textbook, then you will not find the explanation of the formation of this kind of peak, right? But what I think why this peak is forming here, very easily what you can do here, see how it is forming. Actually 70 was the peak and this was the peak at 55. If you subtract this value, then of course you will get 5 from here, 1 for 15, right? So you're getting 15, and you know the 15 is what actually the CH3. So somehow you can remove the CH3 from here. How you can remove the CH3 from here? Easily you can get this value also. Say you are removing this what I can say, this CH2 from here, right? And one of the hydrogen from here. So you'll get this CH3. What you left with? CH3, C, CH2 and CH2, right? And of course this positive and a dot would also be there. So however you can adjust all these things. However, this is not looking a very good one, but you can see this is the only explanation by which you can get the peak at 55. This structure may be wrong, because you see the explanation is not there in any textbook for this 55, right? 1, 2, 3, 4, that means 48, right? Plus 3, 4, 5, 6, 7 plus 7, that will give you the 55. So this is the only way by which you can explain the formation of this 55, and it is quite abundant also. If it is abundant, definitely it would be having you can rearrange this kind of thing in this way. Say it is CH2, this is double bond CH, right? And this is again you see CH2 and CH3 type of thing. 1, 2, 3, 4, right? And 48, 3 to 5, sorry, not like that. This is CH2 actually, right? 2 to 4 and 5, 6, 7, that is 7, that is, it will give you the 55, right? So actually this cation, if this positive charge is somewhere here, so this is actually the stabilized one, or you can put the positive here. So somehow you can make this one, right? So these peaks I have explained, right? And see this 42, if you want to explain the formation of this 42, it is quite easy, right? And it is, you see in this case, this 42 is also a base peak, right? You see it is a base peak because it is having the highest intensity. Now you can very easily see how this 42 is forming here. So the formation of for this M by Z 42 is quite easy here, right? I can explain this one. So how this 42 peak is forming, right? So this was your molecule. You can write it in this way. Say this is your, say OH, right? This is CH2. Another CH2 it is here, and then CH2. 1, 2, 3. this is 4, and say this is 5, right? This was the molecule actually. So this I have already explained you, and this is positive and dot. In this way you can write it, right? And what could happen, one of the hydrogen actually from one of the hydrogen you can knock down from here. So this you can write in this way, this is CH2, right? This is hydrogen, and this way you can see. And what would happen, this hydrogen along with one electron can go up, and one electron you see here from down, right? And one electron actually would go from here, and one you would here, and one electron you would here. So what is actually happening here, you are removing first water molecule, right? And after that water molecule you are removing this ethylene, so that is C2H4, right? So what you left with, you left with this CH2, right? And one electron is coming from here, one from here, it will now double, and this would be your, say, CH3, right? So hydrogen scrambling is always there. This kind of species if you are getting, right? So this will give you, say, 1 2 3 36, 3 4 and 6, that will give you 42 kind of thing, right? So this you are getting actually. Of course this positive and dot would also be there. So this 42 explanation actually the formation of this kind of thing, elimination of water molecule after this one, right? So this 42 is actually the base peak, which is very important, right? And you have to explain this 42 every time, you know, this base peak is very important. And finally you can focus on this 31. So this 31 peak is again, it's very common, right? How it is common, you see, I can explain this one also. Say this was where CH3, CH2, 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 1 2 3 4 5 and OH, right? So in this way you can write dot and positive. So loss of the alkyl group, and I told you the largest alkyl group should remove from here very easily. So 1 2 3 4. So this alkyl group actually lost from here as a radical, right? So this would go along with this one, right? And you can have this one, right? And of course one electron would come from here. So you will have this kind of a species. You can see here CH2, this one, this is double bond OH, right? And this is having only the positive charge because one of the electron you can come from here. So if you count the number, see, carbon is 12, hydrogen, 3 hydrogens are there, and 16 is there, right? If you add, it will make you the, that will give you the 31, right? So in case of this primary alcohol, right, I have explained all the peaks, 71, 55, 42 and 31 and 88, right? So this is how you can explain the alcohols, right? But however, see what the explanation I have made, this 45, it is actually the correct one. But what can happen, you can practice to draw the more correct structure. Fine. Now if you move to the, say, second kind of structure, right? Very quickly I am going through this one also. So you can see it's a secondary alcohol, right? If it is the secondary alcohol, then obviously the molecular ion peak would be almost offset in this case, right? Then 88 you are getting. This 73 I have already explained. This is actually removal of this H2O. So nothing wrong in it. So this not 73 actually, sorry. This was 88, right? And this was 73. So this will give you the 5, right? 8 minus 3 is 5. And then you see 25. Okay, fine. So what is happening? So not, this is not actually your this one. Actually it is 15, right? So 15 is quite fine. How we can do it? Of course, you can remove one of the CH3 from here, right? So this will give you minus CH3. If the CH3 remove from here, then obviously you left with the species. This was your CH3, right? And this initial one is CH2, and this is again you can find your say CH double bond OH kind of thing, positive on it, right? So if you count the weight of this one, 1 2 3, that is 36, right? And not, see, 1 2 3 4, see, 1 CH2 would also be there. Okay, so 1 2 3 4, that is 48, 12 for your 48, and then 16 for your this hydrogen, this oxygen, and then your hydrogens, 1 2 3 4 5 6 7 8 9. So you can put 9 here, right? So 9 and 6 15, 15 and 8 is 23, right? Carry 1, so sorry, 2 5 6 7, so you're getting at 73 actually. So this peak, this one actually, right? So the 73 is actually due to the due to the removal of this methyl group here, right? And this 55, I have already explained you how we can make this 52 55 actually, right? Now you see, in the previous case we were getting the peak at 42, but here in this case you are getting the peak at 45. So this is the 45 peak, and you have to explain the formation of this 45. Now how we can explain this 45? This is again quite easy. What I told you, another fragmentation mode. What could be the another fragmentation mode, right? That means the largest alkyl group will remove preferentially, right? So you can remove from here 1 2 3, that means C3, 3 to 5, and from here actually to 7, C3S7 you can remove. So what you left with? You left with this CH3 here, fine, and then you're having your say CH2, sorry, not CH3, double bond OH kind of thing, right? Now if you see, this is 12, right? Wait a minute, this is 1 2 3, so you left with 1 2, sorry, very sorry. So you left with this CH3 kind of thing, right? And then you can have your CH from here, then double bond OH. Okay, fine, this could be the species, right? Positive and dot of always there, right? 1 2, that means 24, this is 16, 3 4 5, you can write it 5 here, right? So 6 4 10 5 15, carry 1 45. So this is how you can, due to the formation of this species, you are having this 45 peak. So this is sufficient to explain this one. See, as I have already mentioned, it is not possible for anyone to interpret each and every kind of the peak, right? We generally try to get the maximum information from that one, but this is how you can explain the alcohols, right? Now say if you want to move little further, see, however, the length of the video is now going pretty increasing one, but again you can see this is again, right? So 88 is there, right? Again you can explain the formation of this 59. So this 59, see what you can do, this is 88 minus 59, that means it will give you 18 minus 9, then 7 29. So it is what it is forming, actually you are getting the peak at 29. So 29 correspond to which one? That is C2H5, and you see one carbon and second carbon. If this alpha cleavage, see, alpha cleavage is very common. So if this has gone here from here, so what you will get here? You will get here CH3, this CH2 you will get, right? And then you will have here this kind of a species. Got it? Okay. So 1 2 3, 36 plus 16, and then 3 to 5 6 and 7. So if we add 7 6 13 6 19, 3 4 and 5, so you can get this 59 actually also, right, with the removal of the ethyl group. Got it? And then you can have another peaks also. So you can verify these peaks very easily. This 41 actually, how you can get this 41 actually? So this is not from this 59 actually. So initially you are having it 88, and now you are having it's 41. 8 minus 1 is 7, right? And this is you see the 47, right? So you have to look for this 47. How you can go for this 47, right? So again you can check, you can verify, because see, I have explained all these things earlier. Where was the graph actually, right? So this you can work out of your own by your own, right? If you are not getting the answer, then you can obviously ask me in the comment section. Obviously I will give you the answer, but see, all these things cannot be covered because the length of the video would increase so much actually. Now last, you see, in case of the aliphatic alcohols, right? So however, see, one point I want to make here, why this peak is actually, this 59 peak is the base peak. That this is one can ask, right, why this 59? See, I am removing this ethyl from here, right? And if I remove the ethyl from here, so this removal will also give peak at 59, this removal will also give you the peak at 59, right? So if both give, that means of course this is one probability, this is another probability. If the probability is high, of course it will reach maximum to the detector. So that's why it is the base peak actually, right? And of course this is your say in the aliphatic, this is the last one, right? So how does it, see, 73, you know, 88, see, this is the tertiary alcohol, right? This is the tertiary alcohol, so you are not getting the peak at 88 you are not getting this time, fine, but you are getting at 73. So you know 73 actually, this is neutral logical, this is the concept of the neutral logical losses. If you are not getting the peak here, and somehow due to the see, by the knowledge of this neutral logical losses, you can quickly say, okay, if I add 18 to this 73, right, you are getting, sorry, 15, 73, and say if you add 15 to this one, and then, so this was your 70, sorry, what has happened here actually? So this is actually, sorry, this 73 actually is due to the loss of this methyl group, not this one. So if you remove this from here, 88 was already there, 88 was already there. If you remove one methyl here, so you know 88 minus 15, that will give you 3 at 73. So this 73 actually you are getting to the loss of this one. Got it? Now then again you can see this group actually will remove from here, that means 59, and you know if you are getting the peak at 59, of course this 88 was already there. If you remove 59, as I have explained, this is 9 again, and this is 29. 29 correspond to the C2H5, right? So this C2H5 actually the removal of this one, but these two are non-equivalent this time, right? So this will give you one peak, and this will give you another peak, right? And of course it would be stabilized. Actually how it is stabilized I explained here, right? 59, this is actually the resonance kind of thing in this. So it is most stable one, again it is reaching maximum to the detector, it is the base peak. Now you can come here for this 55. So 55, right, I am not going to explain this 55, right? Why? Because I have explained already the formation of this 55, right? So you can work by your own, right? So how you can, however hint is there, you can remove this one also, right? After the removal of this one, you can remove this one and this one, so you will get that peak at 55, right? So you can see in the book already it is not mentioned these peaks, so it is not necessary to do all kinds of these things. Fine. So this is all about the aliphatic alcohols, right? Now you can have your another alcohol here, right? You can have your another alcohol. Now this alcohol is actually the cyclic alcohol. Fine. For cyclic alcohol, you see, you can note down the rule here. Alpha cleavage is there. M-1 is very common in this case. If alcohol is cyclic, M-1, that means molecular ion -1, that means loss of the hydrogen. This actually the difference between your open chain alcohol and your cyclic alcohol. In case you were not finding that M-1, but here this will give you the M-1. I'll explain how we can explain this formation of this one, right? Then after that you see the alpha cleavage of the ring bond followed by the 1,5 hydrogen scrambling. Scrambling means shift here. It is shift actually. So 1,5 hydrogen will shift after the alpha cleavage to the ring bond. This will give you, this is the another mode of fragmentation. And again the second cleavage would occur and the propyl group would lost from here. right? And to form the acrolein. Acrolein, you know, this is unsaturated protonated acrolein, not alcoholin actually. Protonated acrolein, and you know this acrolein is unsaturated aldehyde. It is the pretty stable one. So sometimes it can give you the base peak also. Fine. And then of course dehydration would be there, right? And dehydration mechanism I have explained through, if for 3 or 4 see, it is from the 3 or 4 carbons away from the bicyclic radical cation. So you can see here, I'm going to explain this one also. So how you can explain the spectrum here. So it's again not a very difficult task to explain all kinds of things. Say what I can do. Okay, I have this. So you can focus on this one. So what you can do, see, this was your, say, alcohol, right? This scheme which I am explaining right now, it is given in every textbook, right? So this is OH and this is H, of course, and a positive and dot over here. This is actually the molecular ion, right? And if this is the molecular ion, and you know this is the cyclic alcohol, so you are getting the peak at 100, right? Because the molecular weight of this compound is 100. So this is actually your M by Z 100. So you are getting the peak here. And again you are getting the peak at 99, sorry, that means M minus 1. So you will look for the M minus 1 peak. So M minus 1, this hydrogen you can very easily knocked out from here. How? This electron can come here, this can come here, this hydrogen can remove as radical. So you can write minus H dot, and your remaining species would be just like that, OH positive. And since this 100 lost 1, so of course you get 99. See, this, the intensity of this 99 is quite low, but this peak is quite important in case of these alcohols. Okay. And then again you can explain this 82 actually. How this 82 is forming, you know, this 82 actually, 100 was your molecular ion peak. If you remove 18 from here, right, that will give you the 82. That means dehydration is occurring here. Fine. So this dehydration will lead to the formation of that one also. Clear? So 82 is quite easy to explain. So from you see, one can argue how we can remove this one. So again it's very easy. What it can do, say this was your OH, and of course the hydrogen was there. So what can happen? This OH, right? So this is 1, this is 2. So hydrogen is also there. So it can undergo 1,2 type of elimination, and this 1,2 elimination will give you the peak at 82. So you can explain this one. But you see, in case of this, again you see here, this peak is quite important. This is actually peak at 57. You see in this cases, all the peaks are not labeled actually in the book itself, right? This is actually the scanned copy of this Pavia Lampman book, right? Spectrum taken from the Pavia Lampman. So this 57 you have to explain, and it is little logical to explain this one, and it is technical also. So you can explain in this way. For this I can show you these things again, right? So what you will do, see alpha cleavage, this hydrogen cleavage, right? Sorry, hydrogen scrambling. After that, second alpha cleavage would give you occur, and loss of the propyl radical will give you, and acrolein formation. So what I will do, I'll make a acrolein from here. This is actually the important one, and this is the probable question if you are going for your exam. So this is the probable question from alcohols which you can find, right? So how it is forming, very quickly I can show you. So actually this was the case. This was OH, this was H, right? And say this was positive, this was dot. Now the alpha, see this bond is alpha, this bond is alpha. So you can break this one or you can break this one, right? Whichever bond you want to break. And of course 2 hydrogen were already there. So what could happen? You see, this bond would break and 1 electron would go up in this way, and of course 1 would come down from this pair, right? And out of this, you see, one of the electron would go here, right? And one of the hydrogen actually would join this one, fine, and then you will have a species. See, this was your OH, right? Single was already there. Now it has become double actually. This is C. This hydrogen was already there, so you can write it this hydrogen here. Okay. Now this and this one hydrogen have moved from here. So, or you can see for time being you can forget about this one. So these two hydrogens are there. This and this. See, this alpha cleavage had occurred already. So this dot you can put here. Right. So this is one way. Now what you can see again, this one of the hydrogens, say this one, this can move here. If this is moving here, of course one of the electron would remain here, and you will have the species OH, double bond CH were already there, and of course this would become now CH3 because one of the hydrogen have moved here, and you have the dot here, of course along with one hydrogen. Got it? Now this you can very easily rearrange, right? Propyl group will remove from here. So 1, 2, 3. That means CH3, CH2, and again this CH2 would remove as radical, right? How? One electron from here and one would go up, right? If one would go up, then of course this you can have OH, right? Sorry, I have not put it positive over there. So this is positive here again. Double bond were already there. This is C, this is H, right? And if you come here, this is actually CH, and if you do here, this is CH2, right? This is already there, fine. So this molecule is actually what? If you remove this hydrogen here, this is acrolein. Now you have put it this hydrogen here, this is protonated acrolein, protonated, right? And if you count 1, 2, 3, that means 36, one oxygen, that is 16, 2, 3, 4, 5, right? 5 here, 6 is 12, 5, 17, 3, 4, 5, 57. So you are getting the peak at 57. So this acrolein is pretty important, and this is not very difficult task, right? Why it is not difficult? Because it is there in the textbook. All the textbook it is there, right? So you can come in this way. So you are getting this one, and you are getting this one, and 88 you know this is actually what? 88 is the dehydration. So in the textbook, in the Pavia Lampman book, the formation of this H2 after the removal of H2C, dehydration would also be explained very beautifully. So you can go through the textbook, or see you can go through the textbook, or what you can do, see, I can check whether I remember that mechanism or not. Say somehow, say this was your species, again I am drawing it. So this was OH, this was H, dot and positive, right? And actually it undergoes the okay, fine, now it is good, it is undergo the bicyclic system formation, right? Dehydration would actually occur from here. So this is actually positive, this is dot, and plus H2O, right? So this actually will give you this one, but this is not the only species. Textbook it is also written that actually this kind of species would also there. Of course this not, you cannot put anywhere here positive here. So this will, if you count total number, then you will find, okay, 1, 2, 3, 5, 6, 72 is already there, right? And 72, 73, 74, 75, 76, 77, 78, right? 79, 80, 81, 82, right? So you see 6 hydrogen are there. So sorry, not 6 actually, 2 to 4 to 6 to 8, 9, 10, right? 10 is there actually. So 82 you are giving this one. So the cyclic. So this is how you can explain these spectrum of your alcohols. So very quickly what I can do, I can explain the other things also, but I am not explaining all these things in this video. So if you want the explanation on this, so I'll make a separate video for the phenols, because the length of the video is going too much, right? So right now I'm stopping here, right? So if you are watching the video for the first time, so please like the channel and do share with your friends. And don't forget to press the bell icon for the latest notification, right? Thank you very much.